Welcome to velocity. So we're going to be talking about velocity, specifically different types of velocity. But first, what you need to know is what velocity is. So when we're talking about velocity, velocity is the rate of change of position. So if we're talking about miles per hour, I'm talking about the rate of change at a specific position, okay? Now, speed is different from velocity very slightly, okay? Where speed, we say, is the absolute value of velocity, or it's the same idea, but when we talk about speed, speed is always positive. Speed does not care if you're going forwards or backwards. If you're going 20 miles an hour in one direction, you're still going 20 miles an hour in the opposite direction. Velocity takes that change of position into effect. So if you are going backwards, you would have a negative velocity, versus going forwards, you have a positive velocity. We're going to talk about two specific types of velocities. The first is angular velocity, and the second is linear velocity. Okay. Angular velocity is always calculated in radians per some amount of time. Now, the time unit does not matter. The important aspect is we do have the unit of radians when talking about angular velocity. Or I'm thinking of how many radians am I moving per unit of time. For linear velocity, this is your more standard. So that's like your miles per hour, feet per second. Okay, so it's some kind of distance over time. Okay, so think about our rate formula. Linear velocity is very similar to rate. Distance equals rate times time, or rate is distance divided by time. This distance can be any type of distance. It could be feet, meters, inches, miles, yards, whatever it is. It is just not radians. It is not revolutions, because those are two very different types of calculations. They're not really giving us a distance. Now, the reason why we use this is so that we can take something that is maybe in an angular velocity and transform it into linear velocity. Okay, so for example, say I have a ceiling fan that makes 9 revolutions per minute. Okay. And then the radius of that ceiling fan is 3 feet. Now, the reason why we need to know the radius, you'll see when we do our dimensional analysis. And I want to find both my angular and my linear velocity. For both, we are using our dimensional analysis. So for my angular, I'm going to start out writing my fraction. I have 9 revolutions per minute. Now, reminder for angular velocity, we are always looking for radians per some amount of time. So I really don't care about the minutes here, but I do care about the fact that I have revolutions when I should have radians. Now, this is something that we already did in our last video. If I want to get rid of my revolutions, I know that one entire revolution is 2 pi radians. Okay, that allows me to cancel out my revolutions, giving me an angular velocity of 18 pi radians per minute. Now to move from an angular into a linear velocity, I'm going to take that same fraction or that same velocity. I have 18 pi radians per minute. Now again, for linear, I need some distance per time. That is not radians. So I know I have to eliminate radians. Now, we haven't talked about this in a minute, but remember, 1 radian is referring to the distance around the circle. That is a radius. So I know that my radius is 3 feet. So I know that 1 radian, should be a times, is 3 feet, which allows me to cancel out my radians, leaving me with a total of 54 pi. Use my units remaining, which are feet per minute, to get our linear velocity. Okay. This was a lot of steps. Now, sometimes it's not going to ask you for every little thing, so you have to read your problems carefully. For example, if I gave you this next one, I have a circle with a radius of 12 feet. That makes 5 revolutions every minute. I want us to find the linear velocity, specifically in the units miles per hour. So this seems like a lot, but really all we need to do is know that we need to make it to miles per hour from starting at 5 revolutions every minute. So let's dimensional analysis. I have 5 revolutions every 1 minute. Okay. First thing I see is I have minutes. I need hours. So let's deal with that really fast. I know there's 60 minutes in 1 hour. Okay. Those will cancel. The next thing I need to deal with is this revolutions. I need to get rid of this revolutions. And what's the one thing we know about revolutions is that 2 pi radians make a revolution. That's our most common conversion that we're going to be using here. So my revolutions cancel. Now I'm left with radians though, and radians is still not miles. So I need to get rid of my radians. The information that was given to us about our radians or about our radius is that it is 12 feet. So I know 1 radian is 12 feet. That cancels my radians. I am left with feet. I am still not done because I do not want feet. I want miles. So I need to get rid of feet. And I know one of our classic conversions from the dimensional analysis video, watch it again if you have not, is 5,280 feet in 1 mile. This allows me to cancel my feet, leaving me with miles per hour. Now all we have to do is take out that handy dandy calculator and multiply it all together. So 5 times 60 times 2 times 12 divided by 5,280 is approximately 1.36, and actually it's not approximately, this repeats forever, 36, don't forget your pi, it's there hanging out, miles per hour. Okay. We are just doing extremely complex dimensional analysis to move from revolutions to some measure of distance. Now, of course, not everything can be that simple. Sometimes we are given a word problem. So we're going to go over 2 word problems together before I let you go do some practice on your own. So, a point on the rim of a wheel with a diameter of 2 yards has a linear speed of 100 feet per second. We want the angular speed, or radians per second, and the number of revolutions in a minute. So we need to find 2 conversions here. Of course, when I am given a story problem, I am always going to draw it out. I know I'm dealing with circles, and I have a diameter of 2 yards. So the entire distance of that circle is 2 yards. But recall, we don't really want our diameter. We only care about our radius. So if my diameter is 2 yards, I know my radius is 1 yard. Okay, that will be the important piece of information. So let's start with our linear velocity. We have 100 feet per second. Okay, and we need to turn this into angular speed, or radians per second. So I know I'm going to need my information about my radians, and I know that 1 radian is 3 yards, or not 3 yards, is 1 yard. But currently, my units are in feet. So I need to first change my feet to yards. If we recall from the previous video, in 1 yard, there are 3 feet. You should have some of these conversions memorized or down on a note card, anything like that. Now that I have yards, I can change my yards into radians. So I end up with an angular velocity of 33.3, repeating forever, radians per second. Okay, but that is not the only thing that was asked of us. We were also asked to find the number of revolutions in a minute. Okay, so we're going to box this as one of our answers. Let's get rid of this work here. Perfect. And now we are going to take our angular velocity and use it to find our number of revolutions. So if I have 33.3 repeating radians per second, I need to change these radians to revolutions. And in a revolution, there are, hopefully you remember, 2 pi radians. Cancels out our radians. I also need to change my seconds into minutes. And I know there are 60 seconds in a minute, allowing me to cancel out my seconds. Now, when I multiply this one, I don't like having pi in the denominator, so I am going to multiply by pi, or divide by pi, I guess, in this case. And you get approximately 318.3 revolutions per minute. Wonderful. Okay. One more story problem altogether. We have a bike tire with a circumference of 87 inches, an angular speed of 20 radians per second. We need to find the linear speed in miles per hour. So let's start with that angular speed. We have 20 radians per second. Now notice they did not give us a radius. They did not give us a diameter. They gave us a circumference. So, a quick reminder, circumference is pi times diameter, okay, calpide, you can't remember. The other way we can write this is circumference is 2 pi times the radius, okay, because our diameter is 2 radiuses put together. I am going to use this information to find out what our radius is. So if my circumference is 87, circumference is 87, 2 pi times r. I simply have to divide by 2 pi on both sides to get that my radius is 13.85-ish, approximately. Okay. Now that I know what this is, specifically, again, use your units. It's still in inches. I can change my radians into inches because I know one radius is 13.85 inches. Okay. Now we are on the move to get from seconds to hours. Okay, so to get rid of seconds, you can go straight from seconds to hours, or you can do it the long way, which is there's 60 seconds in 1 minute, there's 60 minutes in 1 hour. Okay, so we kind of do a multi-step there to get rid of those, leaving us with hours. And then I need to take those inches and turn it into miles. Again, we need to take a couple steps. First, I'm going to go from inches to feet. There are 12 inches in a foot. And then I am going to go from feet to miles. There are 5,280 feet in a mile. My feet cancel. My inches cancel. I'm left with miles per hour. All that's left to do is multiply it all together to figure out exactly what that number is. And it is approximately 3.1, we'll round up, 5 miles per hour. It is complex dimensional analysis to move from one set of units to another. The biggest thing you need to remember is that angular speed is in radians per some unit of time, whereas linear speed is always in some amount of distance per time. And it will usually tell you what units it wants from you. All right, that's the end of the video. You have plenty of practice problems to do about this. So take your time, take it seriously, read the question closely, make sure you are not missing any parts of it.